In this video, we'll talk about two phase diagrams. The first one is P versus nu diagram. The second one is T versus nu diagram. P stands for pressure, T stands for temperature, and the nu stands for specific volume, which is volume over mass. On each diagram, we first see there is a dome. This dome is called vapor dome, which will help us to identify the state of the substance. For example, on the first P versus nu diagram, let's say you have some water flowing inside a pipe. We can measure the specific volume, which gives us the x-coordinate. We can measure the pressure of the water in the pipe, which will give us a y-coordinate. With the x and the y coordinates, we can locate the point. If this point is located somewhere to the left of the vapor dome, then without visually inspecting the water in the pipe, we will know for sure the H2O in the water must be liquid. However, if the point is located somewhere within the dome, then we know for sure the water must be a mixture of liquid and vapor. And if this point is located to the right side of the vapor dome, then we know for sure the water must be vapor. So those two diagrams will help us identify the state of the substance by comparing the location of your point in reference to the vapor dome, so that we don't have to visually inspect what is the phase of the substance. Okay, so on to the left side of the vapor dome, anything must be liquid. And to the right side of the vapor dome, everything must be vapor. And if a point falls underneath the vapor dome, within the vapor dome, it must be a mixture of liquid and vapor. Same rule applies to our second diagram, T versus nu diagram. To the left, it must be liquid. To the right, it must be vapor. And within the vapor dome, it must be a mixture of liquid and vapor. And next, we have two special cases. What if the point falls right on the first half? Right on the first half of the vapor dome. What does that mean? It's an interface between the liquid and liquid-vapor mixture. So if your point falls right on the first half of the vapor dome, then we call it saturated liquid. Saturated liquid, which means the beginning of the phase change. You can think of saturated liquid as the moment when water starts to boil. The beginning of boiling. Same thing here. Okay, and then what if the point falls right on the second half of the vapor dome? If your point falls right on the second half of the vapor dome, which is highlighted in color red, then that means the water must be at the end of the boiling. There's no more liquid left anymore. Every drop of the liquid has been turned into vapor. So we call it saturated vapor. Saturated vapor means this is the end of the boiling process. No more liquid left anymore. Okay, in addition to this, we have some constant pressure and constant temperature lines on each of the diagrams. On the first P versus nu diagram, we can have constant temperature lines. The shape of such a line is like this. It curves down first, and then it goes straight, and then it continues to curve down. This is called a constant temperature line, meaning every point on this line has the same temperature T. You can have as many such lines as possible. For example, the one above will represent temperature T1, and another line beneath it will represent a different temperature T2. You can have as many of them as you want, but the rule is the higher this constant temperature line is, then the higher the temperature it represents. Similarly, on our second diagram, T versus nu diagram, we have something called constant pressure lines. The shape of such a line is to curve up, goes straight, and then it curves up again. Every point on this line has the same temperature P, and just like before, you can have as many such lines as you want. And each line represents a different pressure. The rule is just like before. The higher this line is, then the higher the pressure it represents.